We'll make this presentation today, the three of us, with Emma Lundberg. She's the director of the Subcellular Human Protein Atlas, and Andy Norgren. She's the executive producer of EVE Online. And today we'll talk about a project that we created together during the last year. I'm the CEO and co-founder of MMOS, which stands for Massively Multiplayer Online Science. And that's the name for the concept and also the name of our small Swiss startup. This project that we started is Project Discovery, is bringing citizen science into EVE Online. Now, I want to start with citizen science because that's our focus. As a formal definition, citizen science is when members of the general public are carrying out scientific work. It is when we're helping to find the native structure of protein molecules in folded. It is when we're helping researchers to solve DNA sequence alignment problems in projects like Philo, or classify galaxies in Galaxy Zoo, or when we chip in to map the structure of visual neurons in the brain in eyeball. These are all very popular citizen science projects. The main concept, it's basically scientific crowdsourcing. The main concept is that we distribute the problem set images to 20, 30 people. We gather the results, make some majority voting, and then we come up with a solution. And it turns out that even if some of us are way off, the wisdom of the crowd is quite a powerful resource to tackle these time-consuming challenges. Here I'm sure that I don't have to explain what an epic mission is, but if you've tried these projects, you might know that these are real epic missions. And it's beautiful that we can be part of them. We can be actually meaningful and important contributors to these problems. I've always been fascinated by citizen science, but also I know about some of the problems that citizen science face. And one of the biggest problems is the long-term engagement of users. People love these projects, but they tend to leave them after a couple of classifications. So that's where we came into the picture. And 2 years ago, with a friend of mine, we came up with an idea that instead of creating standalone citizen science games or gamifying the problem, why don't we just take these problems and inject them into already existing major video games as a seamless gaming experience. And our hypothesis was that if we can create a solution where these problems are completely integrated with the game mechanics, with the narrative, with the visual, with the reward system, then with the help of the professionals of the game industry to create an engaging experience, we might be able to transform a tiny fraction of the billions of hours that we spend in gaming. And even that tiny fraction is something amazing in science. That would be a virtually infinite human computation engine to have scientific research. So that was our concept, and we started to work on it, and we created a small company, and first we contacted many research groups, and my lucky star led to Emma and her team. And I'm not going to talk about what she's working on, she will talk about that later. I just wanted to show you a couple of images that she's working with. And when she showed us, we were just amazed by how beautiful these images are and how amazing raw material this is for game development. And on the other side, we contacted the game industry, namely EVE Online. And it was Andy, my first contacted, and she immediately became a huge supporter of the project. And now after a year, we launched Project Discovery, and now I give the stage to Andy to explain what Project Discovery is about from her perspective.
Alright, so hi, I'm Andy Norgren. I'm the executive producer for EVE Online at CCP Games. And we just celebrated the 13th birthday of EVE Online. This game has been live and players have contributed to this one same shared sandbox for that long, since 2003, and just launched a big expansion called Citadel. But we started talking to Attila and MMOS in 2014, and we started talking about the possibility of doing something like this. Could we take this type of citizen science problem and actually integrate it into EVE Online as a proper part of the gaming experience? And when Attila approached me, I immediately thought that this was something really amazing with huge potential, and I was pretty much 100% certain that our players would love it as well. But of course, the question with these things is, how do you actually make it a reality? So I'm going to talk a little bit about how we approached it. So what we found was that we could make this happen by creating a pretty extensive collaboration between us at CCP Games and a number of partners. So the Human Protein Atlas had the scientific research problem where players could contribute. MMOS, they had the vision for this and the ability to bridge between our game and the scientific problem. And then we also joined in with Reykjavik University because they had students who were looking for exciting projects to do as their final projects on their computer science program. And then we could contribute, of course, game designers, supervision, and the access to EVE Online, the game itself, and the vision for how this could become a part, really, of the game experience. And by joining all of these partners together in this project, we were able to make this happen. So the result of this collaboration was a storyline for players where Sisters of Eve, which is an in-game group, are doing in-game as well a crowd science project where they are analyzing tissue samples from the mysterious drifters in the game that are an enemy of the players and that they haven't really figured out yet exactly what they were about. And so the Sisters of Eve recruit the Capsuleers of New Eden to take part in solving this problem through the Project Discovery interface. And I want to show you how our in-game news network, the Scope, reported on this project to show you a sense of really how we fully integrated this into the game world, into the lore, and into the whole fabric of the online universe. And this Scope report starts with some other news from the world, so after a while it gets to the project.
Withdrawal of drifter forces from Amar space has brought a sullen end to their attacks. The Imperial Navy has been embroiled in an endless string of staggering losses, including the assassination of Empress Gemma I, making this a much-needed reprieve. The sudden drifter pullback to the 5 known hive systems are believed to be connected to the Capsuleer reports that gate restrictions in those systems have been removed, clearing the path for Capsuleers committed to pushing back the drifter menace. The conflict has certainly taken its toll on the Amar military, and talks of the withdrawal being a reaction to Sisters of Eve, and Capsuleer actions only adds insult to injury for the Amar. Meanwhile, Sisters of Eve has launched a crowdsourced analysis of collected drifter data entitled Project Discovery and rallied under the banner of Citizen Science Begins With You. They hope to unlock the new drifter tech so that they may be made public and shared with all. This is Lena Amber reporting for The Scope.
So this should give you some sense for how we brought this into the game, but what is the actual game experience? So wherever you are in EVE, you can launch the interface then for this citizen science project. So you can do this while you're mining or traveling or just while hanging out in the station. For EVE players, it functions as a sort of middle in-between activity. And of course we have some players who really do it as a primary activity as well, as Emma and Attila can see in the stats. But you get basically this interface where on one side you have a tissue sample, which is then coming from a real-world image of cells and tissues. And your job is to identify where a green marked protein manifests itself in the cell that you're looking at. So, for example, you might say, okay, this manifests in the nucleus of the cell or in the periphery, and you mark this using the different selection criteria. And you submit your answer, we compare it to what everyone else is thinking, and we give you some results of your classification and your submission. And you gain in-game currency ISK for doing it, and you get experience points, and as you rise in the ranks of this project, you gain analysis credits, which you can then use on some really exciting rewards in-game, like pretty swell combat suits and boosters that improve your performance in-game, and lab codes and other stuff that players are pretty excited about. And EVE players have really embraced this. There's a whole subreddit where people are discussing how to take part in the project, and more than 50,000 players have made like a meaningful contribution to the project, and there's a decent percentage every day that engage in doing analysis and project discovery. And even for those who don't take part directly, they can also access some of this content by basically buying it from those who have earned it as part of project discovery. And Emma will talk about the results from a scientific point of view, but I want to just reflect a little bit on how this project has turned out for us as a game developer. Because there are many aspects to a collaboration like this, and with my business hat on as the executive producer for EVE, I have to find a justification for the project as a whole to make sense as a set of priorities in our company. So overall, this has turned out really great for us. Players are participating, they're really loving it. And of course, it's an amazing opportunity for us as a company and as a game to make this type of contribution to science by channeling our players' willing participation in this. And one way that we were approaching this internally was to give the project 4 really solid pillars for us as a developer. Like, why are we doing this? How are we arguing for this to ourselves? And so the first one, which really drives the project from the beginning, is that it is this opportunity to contribute to a real world good. And of course, when that is the case, there's always some potential for awareness for EVE Online in general, because this type of project can reach a mainstream audience. We, of course, have game news from inside EVE Online that sometimes reaches a mainstream audience, so we're quite familiar with how the dynamics of that plays out. When we have players, like 4,000 players in a battle, and it's, $300,000 worth of online spaceships are destroyed, we know what it looks like when this reaches the mainstream media. And this type of project is maybe a slightly more positive way to reach mainstream media. I think it was a really interesting opportunity for us to provide that route for our players as well, to become visible to friends and family, for example, and so on. And of course, we also saw it as a great opportunity to actually provide good game content, to create part of the EVE game experience that our players would really like. And this is, of course, part of our normal day job. That's what we do all the time. We try to make EVE Online into a game that players really enjoy and add new features to it that players like. So that had to be part of the equation for us. Like, even if we were doing something really good in the world, if we couldn't find a path to actually integrate it into the game in a way that where it made full sense, then we wouldn't really be able to do it. And then a 4th pillar that we found to really have this project make sense was to grow game development talent in Iceland through a collaboration with Reykjavik University. And we already have a collaboration running with them, and this was a way to extend that in a super practical way, where students are, like I said, looking for exciting final term projects in their education. And this became a super practical way for us both to get something like this done without investing like full developer resources on our side. The students were actually able to build most of this what we spent time advising and so on, but the main work push came from those students, and it let us take some of the most talented students coming out of the computer science program at Great University and bring them into the building and working with us, and we've actually now hired one of them full-time as a developer. So this is kind of working out for a lot of people. And having these 4 pillars for us means that even if we don't get a lot of attention for this, for example, in press, which we have gotten a lot of attention for it, so it's not actually a problem, but that's not the sole reason we're doing it, for example. And we're also not just doing it because it's a cool game experience. We're also doing it because it's a good contribution to science. Like, all of these 4 things work together, so when one pillar is maybe kind of faltering, we can lean on the other pillars. And I think this is how this type of project can be feasible for maybe more game developers than us, is that you find multiple legs for it to stand on, so that it doesn't fall over if you don't get a lot of press from it, for example. But there are other solid grounds that are the reason to go into something like this. So, I guess to conclude a little bit, this is such a crazy project in so many ways, and sometimes when I talk to people about it, I say that it shouldn't exist because it has so many, well, I'm kind of promoting how it does exist and why, it worked out for us. It's one of these projects where there are so many components and incentives and people who need different things out of it that unless it was a passion project for a lot of people, it probably wouldn't have worked out. On the other hand, it is something that just needs to happen. It's one of these things that wants to be brought into the world, and I am really, really proud that we have been able to find a path for this in competition with a lot of other priorities which always exist in the world of game development. This needed to be done, and we were able to pull it off, and that's something that I'm super proud of. And now I want to bring Emma to the stage to talk about the real reason we're doing it all, the science behind the project.
So, hi everyone, I'm a PhD member from London and I work at the Royal Institute of Technology in Stockholm in the Nordic Atlas project. And I'm going to talk a little bit about the science behind this game and also the results that we've gotten so far. So to start out with, why do we want to study proteins? Well, we have many reasons to do so. If you look at the central dogma of molecular biology, we have genes, we have DNA, and they are the blueprint for how to build proteins. Proteins are molecules that perform a function. So they are essential for life. And protein malfunction is a very common reason for disease, and almost all drugs on the market act by targeting protein, inhibiting or modulating the activity of the protein. So in life science, it's very interesting to understand protein function and what they do. And some of you might remember this. In 2001, Bill Clinton announced that we have finished the Human Genome Project. We have decoded the Book of Life. This is a milestone for humanity. Of course, it was a great step. We know we have 20,000 genes, and this is 15 years ago, and still we don't know what the proteins that these genes code for. We don't know what they do. We haven't even found all of them. And one of the reasons why this is taking long is because it's harder to study proteins. The DNA is identical in all our cells. We can take blood sample and analyze our DNA, but if you want to study proteins, you have to sample the whole body. Luckily, humans are made in a very clever. We have evolved in a clever way, so we are compartmentalized into functional entities. We have organs with specialized functions, and they contain proteins and other molecules that are needed for this function. And the organs are built up by specialized tissues that are built up by specialized cells that in turn are built up by specialized organelles. So if we could make a map over the human body to see where these 20,000 proteins are expressed, we get clues about their function. So that's what we want to do in the Human Protein Atlas project. And there are many different ways of doing this. We are doing it by probing one protein at a time and using high resolution microscopy. So this is a microscopic image of human cells. Let's see if I can. No, I can't want. The blue, that's one cell nucleus, that's DNA. The red outlines the cell, and this image, the protein we're interested in, is shown in green. I'm a trained cell biologist. I can look at this image. I see that, oh, this protein is localized to the active elements. Then it's important for keeping the cell shape and involved in cell movement. So that's what we want to do. Humans are very good at recognizing patterns, and that's what we want to do. But since we have 20,000 genes, we have a lot of different cells, it makes a lot of images. So we've spent the last 10 years generating a lot of images like this. And this is why we think citizen science is such a good help for us. So what we're doing is that we're building a freely available database, the Human Protein Atlas, with this image-based map of human proteins. And it's one of the largest biological databases in the world. We have a lot of users, and we have, in average, 4 scientific publications being published every day that use data from this database. And it's all also funded by a non-profit organization, like the Vandenberg Foundation. And I'm not going to tell you, we spent 10 years generating this data, so there's a lot of, well, most of the things we do are in the background of these images, but this is what it looks like at an ordinary day of work for me. It's a lot. So again, why do we want to, why here? Why do we want to do citizen science? Well, because we have a lot of images, and these images are very rich in information. And of course, we have annotated all of these images, but we've realized that there are more patterns than the ones we have annotated. So we want the players of Eve to help us refine our database, classify more patterns. And also it's very interesting because we can compare the performance of a few experts with many gamers and artificial intelligence. So it's also very interesting from that point of view. So if, I don't know if anyone here tried the game, but if you haven't, this is again what the images look like. The cell nucleus in blue. There's some landmarks to help you find the cell. And then we have some red, barely shows here, red staining that also outlines the cell. And then we have the green pattern. And in the game you get a tutorial to help you recognize these different patterns and classify them, so you would know this is a plasma membrane pattern. This is a cytoplasmic pattern. This is mitochondrial pattern. This is the pattern of the Golgi apparatus. And if you want to, you can read more about the biological function of these proteins and learn more about that. But if you're not interested in that, you can just recognize the pattern, classify it, and get your in-game rewards. So this was launched in a bit more than 2 months ago. So we've been overwhelmed by the participation and the interest we've seen in this project. It was, I think, 10-fold higher than we expected when we started it. And the question that remains then is, of course, how real is the data? But if we look at some numbers, for the first 6 weeks, we got almost 8 million image classifications. And the players spent 18 million minutes playing this minigame in Eve. And if you do the math, that translates into 163 Swedish working years. So I was completely mind blown. This is amazing. Players they're fast, they're apparently tireless. So it's amazing. But what remains to be seen is if the scientific quality of the data is good enough. And I think it is. And we can tweak the game to make it also. So the gamers have classified a lot of different images, and I'm not going to go into the results in detail because we're still processing it, but I can just show you an example. This is a structure called rods and rings, wheel structure. It's quite recently discovered. The function is not known. It has something to do with antiviral reactions, that's all we know. And it has 3 known protein components. And the players of Eve have identified 109 new potential proteins to be in the structure. So this is a great starting point for us to make discoveries in biology. So I would say that we don't have to worry about the quality, scientific quality of the data, because we can find good pieces in it, but I'm still very excited to analyze the whole set of data. So I really believe that players can help us to make a better understanding of cell biology, help us to map the cell, and help us to make the Human Protein Atlas a very valuable source of information for researchers all over the world. And as Andy said, besides the actual improved scientific data, we've also got a lot of media attention, so we're making people aware that proteins is not only something that you eat, actually also is very important molecules, and, well, the media attention has been very massive, I would say, and this is just some of it, and these are from the last couple of weeks. So we even got the Wall Street Journal to write about it, and the one to the top left is one I'm most proud about, Nature Biotechnology. That's high-impact scientific journals, writing that citizen science lures gamers into Sweden's European Atlas. So this is actually proof that we got the scientific community standing on their toes, waiting that, well, maybe they can actually make something good out of this, and I think that we can. And coming from the non-gaming community, I'm also amazed of how the players have embraced this and, well, the community in EVE. And I find it kind of hilarious that I give classes at the Royal Nordic Institute, but now we actually teach classes also at EVE University. Isn't that amazing? And also the feedback from the players. I have some of my favorite quotes here. Top left, a player comparing us to potato chips. It's addictive. I just have to classify one more. And another one saying, this is the second comment we get a lot. I would participate even if there were no in-game rewards, knowing that the efforts feeds into a larger purpose. And also the last one. It's a bit weird when your passion for science gets such a boost due to a video game. Well, we like that. I'd like more science to everyone, and with that I'll hand over to Nikolai.
So now you have a deeper understanding of what project discovery is. And I think without too much exaggeration I can say that it became part of gaming history and also citizen science history. It's actually the first time that a serious game is integrated into a major video game. It's the first time that an acting scientist has an NPC character in the video game. It's the first time that high-profile scientific journals like Nature Methods published screenshots of a video game. And actually just 2 weeks ago at in Reykjavik at FanFest, we had the very first citizen science live PvP tournament, which was quite amazing. And as of today, with this 2 months history of project discovery, it is the biggest citizen science effort worldwide. So it's pretty mind-blowing. But a very valid question is, why should you care? And of course it's a nice story, and I hope it's good to see our enthusiasm. But my ultimate goal here is to convince you. I mean, you are the ones who are creating games, you are the ones who are designing them, they're developing them or releasing them, and I want to pitch to you to hop on board and be part of it. For one thing, as Andy mentioned, this is a project that can make the world a better place, and you can do it with a very high impact and also with your core activity, and that doesn't come too often. So in itself, it's really rewarding. We just announced our cooperation with Gearbox Software, where Randy Pitchford, president and founder of Gearbox, told me that if they can contribute to getting any closer to cure cancer by embracing this feature, that would be the biggest reward for them. And I think it's very important that there is more to it. It's very important that it aligns beautifully with the business rationale. This is a feature that indeed is a very cool and engaging feature in games. Players love it. I mean, 8 billion classification doesn't just, it's not just created by compassion. Also, we deliver content. We deliver very cool content for game development, and as you all know, content is gold in game development. Of course, it can be a bit of a leap of faith to let third party inject content and deliver content directly to a player base, but I think our example showed showed it that it can yield amazing results. So also a very important question that whether it's viable or not. And from our part, we created an API which connects science and games. So it does all the heavy lifting of citizen science. So you only need to implement a thin client in-game, which is a reasonable effort. And finally, part of the question of viability is, how does it match to my game? And I created a couple of images, a couple of sketches to show you, how I can imagine this happening. This one, for example, a photo in the middle, which was taken by an automated camera in the Serengeti National Park. It would be an amazing match for a game like Zoo Tycoon. And also you can imagine like automated cameras taking pictures of birds and integrating it with a game like Farm Simulator, stuff like that. Also, analyzing cancer tissue images on your people in Fallout 4 would be amazing. It's not just visually a perfect match, but with a very good match with the storyline, with the radiation-infested world of Fallout 4. Of course, I know it's a bit of cheating because Fallout 4 has monochrome graphics cards, so but there are tons of microscopes lying around in Fallout 4, so it's absolutely doable. Then this one is with Civilization Beyond Earth. It's the same images that we already showed to you. It's just again perfect fit, and maybe a newer, more recent title, No Man's Sky, where in the middle you see a blood smear sample that actually is used to analyze or diagnose malaria. So you are hunting for malaria parasites. These are, I would stress, these are just my concepts. These are not projects that we're working on, but it is just to show you that it's possible to integrate these features into game without killing the game experience. And I'll finish with this one. Of course, this is not my design. This is the actual interface in the game. We're very proud of it. I'm very happy with that. It will be a perfect background for the Q&A part. And I just wanted to tell you that I hope that there will be many new projects connecting science and games, that we managed to plant some seeds here, that we managed to raise your interest, and we'll see new projects like Project Discovery in the near future. Thank you. Any questions that you have?
So my question is, we are not necessarily using a neural network or deep learning algorithm to analyze the videos. What do you need people to use manually?
Yeah, so we're doing it by artificial intelligence also. I think it's good for different purposes. The problem here is that it's many different cell types that looks differently, and then there's a mixture of patterns, and the patterns can be mixed. You can have many different patterns that are mixed to different degrees, and the classifiers we had so far based on AI didn't perform very well with big patterns, but they're really good for single patterns. But I'm sure, I don't know, it will be an even fight, I think.
Because you can use the same integration with games and take the CPU power.
Absolutely.
Yeah, now when you have like 8 million samples, how do you use them to further the research?
Yes, so we will use it both to these rods and wings, we'll make further experimental follow-up studies with, but we'll also integrate this data, these refined classifications, into the Proteinatus database. We're launching a new version in December at the American Society of Cell Biology meeting, actually together with Science magazine, so there will be a poster in Science, and then we're integrating the data into the database. And as for the AI, we got a lot of requests for training sets, just people that want to make their own attempts with that AI solution, so I think we'll make something to help people do that also.
Do I need to train any skills to do this in EVE Online? What's the training time?
No, you can, and for anyone who is interested in trying it, you can just just get a free trial to Eve and do it straight out of the box. So, I mean, that's part of the design challenge, right? I mean, normally with features in Eve Online, there are skills you need to train, there's equipment you need to acquire, and that was part of the design challenge, is to find a kind of a middle ground where we don't block the access to the feature, obviously, and you can launch it from anywhere, but still have it connected enough to the game experience that the rewards are relevant and so on.
How long did it take for you to actually make all the things for EVE Online to support that from the initial idea to the full version?
So it's very difficult to count the actual hours, but one of the clever parts about how we did the project was that we started completely between MMOS and the students at Reykjavik University, and they made a browser version of the minigame. So before we even touched it in terms of our client code and our server code, the thing was already working, which made it very fast for us to then integrate it into actual game. Because investment-wise, often in developing on a game like Eve, having a developer get their head around what the problem space is and try and find a solution is often actually more expensive than just implementing something that is quite well known. Basically copying the implementation, lifting it out of the browser prototype into the game was very straightforward. And that was actually eventually done by the students in the first place, because once they were in the building with us, they could just get a tiny little bit of help to understand how to use the completely custom game engine that we run EVE Online off of. But then once they got into it a little bit, it was really fast for them to actually port it. And then we brought some UI design, quite a lot of design input and oversight in terms of designing the rewards and the lore and the kind of storyline, how it fits and all of that. So we have a team that has been dedicated to it, but not full time. It's been more of an advisory role and so on. So the project as a whole has taken a long time, but in terms of our investment efforts, we have been able to keep it extremely reasonable, mostly through this collaboration with Reykjavik University, which is also hugely valuable for us because it's this talent pipeline question where we want to support young developers coming out of the school system in Iceland going into development either with us or with another Icelandic game dev studio.
One more question. Is citizen science also including projects like that relate with astronomy, let's say Kepler, kind of searching for planets and this kind of stuff? Is that on the list, or they're just more involved into solving problems that we already have?
Actually, we are now investigating what our projects will include in the online, and exoplanet research is one of the best candidates. So we're working together with the University of Geneva, where Michel Mayor, who found the first exoplanet, was leading the institution, and he's still there, and so we are setting up a collaboration with them. Also really interesting that the API is turned to be quite a flexible approach, so our other solution that we're working on, also again with the University of Geneva, is to put real life research data into MOOCs, these open online courses, because it's basically the same concept. We have an online community who is super enthusiastic about giving their best at solving problems, and we said, well, why they are spending their brain power on solving made-up tasks by a PhD student, why don't they work on real data? So that's going to be our next project soon out. The same kind of technology.
Thanks.
Yeah, thank you.